a simple Vulkan. First, you need to download Git, CMake, glfw. glfw will support C. CMake will build glfw. It'll also build something. Well, the Vulkan samples, if you want to build those, just to show off that it works on this computer. This example, for example, is giving me a hard time. It's not. It says it's rendering at all this fast frames per second, and then so when you try out the samples, it gives you a heads up. And the way that the samples work is a little buggy too. So you have to watch out. So this is the hello triangle. Now, this tutorial, I want it to be about setting up the project, doing the weightlifting grunt work behind setting up everything, and explaining this by reading the specification manually, actually going in and doing it. So when you have your project set up, like right here I have a OpenGL project set up, but don't mind it. It's just here for reference of like a shader and how it should look like. We could double reference after we get started. So I'm going to add a project. I'm going to call it Learn Vulkan Intro 1. Then Learn Vulkan Intro 1. At source files, add a file, new item, and I'm going to name this Learn Vulkan Intro 1.c. So we're going to write it in C. Why C? Because we want specification 1.0, not 1.4. I know 1.4 is out. You can go check our Vulkan. Once you have Vulkan SDK installed somewhere in your drive, I put it on my K drive where I have a lot of space and it's a SSD. I could look at the statistics system diagrams. Yeah, a lot of interesting information is here, especially for us that are new at this. Whether or not we've used OpenGL, DirectX, or Metal, or OpenGLES, or the old graphics.h, which is basically what I've learned without anybody really telling me, is kind of like what this is. It's just basically how Carmack, back in the day, wrote Doom. And what he did was kind of graphics driver closer-ish than OpenGL, and then later OpenGL kind of took over because it had more graphics capabilities. Okay, so the first thing is to add glfw to the project. And we'll add a debug version. So you would have to compile glfw, pull up CMake. You would extract CMake, find glfw, compile it, and here I'm showing how you compile shader.rc. You build it, you open it later in Visual Studio, build it again, build the install, and the install will install it. So make sure you install it somewhere you know. So for example, I put my CMake install prefix to my game engines library shader.rc install. So you'll need to build both shader.rc and you need to build glfw. I don't think I built glfw, so let's go ahead and try that. If we don't have time, we could just use the pre-made version that they have on the website. There's also another download link, but I didn't provide it. So you just go GitHub, GL, FW. Somehow that screwed up my search. And then you would, once GitHub is installed, mine's already installed. I can't really uninstall it to do the tutorial. It would just be a waste. I'm trying to get this done really fast, but still following all the specifications, getting device ID without having to do like 20 tutorials. So I have a source folder. Make sure I have no glfw in there. I don't have a glfw in this folder that I built. So I like to run git clone recursive -- CURSIV. So make sure it gets everything that it knows about. It doesn't always work, obviously, because not all GitHubs are build success. They're build fail sometimes, and you just have to go with build fail. That's just the way building things goes. And glfw is nice because it gives us access to Windows. It also gives us access to Linux X11, Linux, the other one, Wayland, and I guess you could have Molten Core on Mac too. So it runs Vulkan like on Metal. And I don't know quite a bit about that, but I know a little bit more about Metal than I do about that. So, all right, so we got glfw somewhere on the computer. Let's go make CMake pick it up. I like to use the UI version on Windows for CMake. For CMake on Linux and like Raspberry Pi, and I use the command line version. On macOS, I also use the UI version. So it's just kind of, it's a preference thing, but at the same time, it's what you get used to. Because of how on Windows and Mac, it's just easier to use the UI version. So I think that's why I prefer it. So I extracted glfw into this folder. There's going to be another folder right now, because as soon as I take this folder, then I open a CMake. So this, we could also build shader.rc again for fun. This is how you set it up. You put your, for me it's case source glfw, and then I just copy paste the same folder, write build. Then I configure it. Yes. I configure it for Visual Studio 2022. Now you can configure this also for WinGW makefiles, NMake, Borderland makefiles, MSys, which is also like a different WinMG, and still compile it on Windows. So there's different styles of Windows compiling. We'll do the most, I think, common. Most people are more commonized to use Visual Studio. So we're using Visual Studio 2022. But we're still doing something kind of uncommon, which is following specification 1. And we will install this into our source folder again. We'll go glfw k/k:/source glfw, source glfw install. So when it generates the file, when it does the install after the build, it'll throw it in there. Build shared libs. I'm going to build the shared libraries so I could use it as a DLL. That'll make my exe smaller. Build glw examples, tests, install. Yeah, we could do all that. glw use hybrid HPG. Force use of high performance GPU on hybrid systems. Let's hit yes on that. See if that gives us any problems. Okay, generate. Okay, so generated the project within glfw build. We need to open another Visual Studio. Compile this. Same thing for shader.rc. I'll do shader.rc sequentially here. So we open the project solution. I should have rebooted before this, but I think it's also the fact that I'm streaming and having a bunch of Firefoxes open does not help. Maybe that'll help. I close all of it. It'll help a little. So, this is also GML can be built, and there's a C-only version of GML, and I haven't really used the C version of it. So we see this glslc.exe. That's our solution file for the projects, and there's 4 projects inside this. An uninstall project, which if you want to clean it up, mess something up, or you just want to delete stuff. Then there's the build project, build all. Then there's the install project. So we have to run the build project that'll build a sub project, which is glfw projects, docs, uninstall, and update mappings. And then there's zero check, which is just a unit test type checker. So we go build all. We'll try to do this the quick way, which is just build all and then install. So we build this. It's a bunch of C files being built, so we know, even just by looking at this. So there is a hello triangle, but their hello triangle, I believe, is a different specification that I'm targeting. So built, right? So the examples they put in here, triangle GLSL. I don't see where the Vulkan one is. I shouldn't be looking at it in here. Should just get on with it. It's always tangents. It takes you down different rabbit holes. I love how it said it right there, that it compiled it. Yeah, building project Triangle Vulkan. But where is that project? I don't see it. Interesting. Okay, Windows. How can I build a project we cannot see? Well, alright. Let's just go and set install as the startup project and run that. And that'll be putting it into k:source glfw install, the directory we just specified in CMake. Hopefully everything goes well. I pray it goes well for everyone. If it doesn't, yeah, I might have to do some reading. Alright, so we're going to just grab this library name right off the bat, glfw3dll-lib. We'll stick that into our Learn Vulkan intro project. We'll put we may have to transfer over the DLL later. So we'll put the glfw3 DLL lib into the additional dependencies of input of the linker into additional dependencies as one of the libraries. Now we'll go to Visual C++ directories and add the library path that I cut from that other path. Make sure, I think I clicked library WinRT directories. That's not right. Alright. Notice that says C++. That makes things like convoluted, but alright. Then we'll add k:source glfw install lib to the libraries folder. We need to also add the include directory. Now, a lot of these steps are really useful if you just generate your code. Like if you go to github.com and you just tell the AI, hey, just make me a Vulkan example with a shader that's subsurface shader and renders a cube. Something simple that it can do, usually kind of accurate. It won't be 100% accurate, and this is why we need to take this like lesson of steps. So the next thing is to go into install folder back, open it somewhere. This is our source folder. Then we have our build folder, then we have our install folder for the GLFW. Now our build folder, we could actually include stuff out of our GLFW and build folder, not use the install folder. It is possible to make that mistake and it'll still work because the include files are the same. Interesting enough, so we include this. This GLFW is going to produce us the window. That's its functionality here. So we know that it's going to include GLFW. Oh wait, is this OpenGL? And so there's native and there's non-native. I wonder what happens if we include native. Like, what does native mean? Library for OpenGL window and input. It's the native file. I opened it. Let's close up my other files I had open. I'm just going to do glfw3.h for now. Include glfw/glfw.h. Maybe write like a main function. I forget how to write the arguments. We can always have that later. Return 0. Set that up real quick. Clean up my shader code. So we are going to write some shader code, so I want to say we're going to have to write. So let's build the other thing that I want to procrastinate and not build and show off. Okay, shader.rc. You extract shader.rc somewhere. Download it off that site. I'm going to pretend that I extracted it and downloaded it. Go shader.c GitHub. Even if you search Bing, it should be the first result. / Google shader.c. You get the code, download, or you could use the proper method. I think you need to use the proper method since it has some sort of other third-party libraries. Let's go check. Well, let's see if I have shader.c inside this folder. Maybe I should just show how I do this. I don't believe I do have it here. No, I don't. So to do shader.c, procedure is pretty similar. Copy the GitHub URL. Copy. Write git clone -- recursive space paste. Git clone -- recursive. It'll download it. It's pretty small. And then set up our CMake. I know I already have it in game engines, which makes this kind of redundant, but just pretend like didn't see that or something. So case source shader.c. We can actually just go like this. And then also put build on the back of it. I'm going to kind of cheat on my end here on the screen, but make sure you do it like this. Oh, and when I cheated, it really screwed me up. It like completely, yeah, just make sure you get, once you get the path right, hit configure. Okay, so the top folder where the source code is k source shader C, and where to build binaries is k source shader C -- build. Configure. Yes. Let's see what we need. We want Visual Studio 2017, 2022. And this is the part that like I didn't imagine myself doing, but it's funny when you try to do this. There's a lot more steps. All right, so then it'll build. Okay, we got an error. Cool. I already built this though. I didn't have any errors before. I have Python installed. Oh yeah, that's the other thing. You have to have Python installed, and gmuck was not found for tests. Yay. Gmock is there. All right, so if you don't have Python installed, install Python. You'll get an error. You most likely got that error now. I didn't because I have it installed. I have Python 3.12 as my main, quote unquote, and I have also Anaconda for all the AI related Python stuff I try to do. Download models off Hugging Face and install those, and some of them need Python 3.9 or 3.10, and they work better sometimes in lower versions. There you go. Error Gmock not found. Required for tests. Do we really need Gmock? I believe we don't really need it. Gmock is Google Test Library, if I'm not mistaken. All right, so git clone https github Google test type git, right? And we'll just go into that. Is this Gmock? Yeah, Google mock. And it's a CMake project. So what we'll do is open another instance of CMake. So again, repeat procedure. Git clone recursive, dash recursive. Visit GitHub page, github.com/Google test .git, or just no .git. Get the URL. I believe I've done this before, so it'll create a directory called Google Test, not Gmock, but it has Google Mock in it, which is what Gmock stands for. Then we will open CMake again. I know I said again before, and then we'll make k/source class Google Test -build. Configure that. Yes, I believe this library is easy to build. For Visual Studio 2027. Open it up in another Visual Studio while we're at it. Get ready to compile it and install it. Make the install directory as soon as this finishes. Hopefully it's successful and not too big. It's a little bit over tiny, I believe. Yeah. Okay, so our install prefix will be k/source Google test -install, because this makes the organization so much better. Do not try to put it in program files. Even if you're lazy, just don't do it. It'll cause you more headaches. You'll be more lazier this way. Build test samples. Build sample programs. Google test. Blah, blah, blah. No, just don't do anything. Build shared libs. Who cares? Just generate. And then, because we're doing this for Vulkan, we're doing this for shader.rc, and it's like doing all those extra little hacky things. And when you have a nice day to drink tea in the morning, then it's fine. But when you don't, so we go to Google Test Master. Open the Google Test distribution. Then it opens finally. Let's just do a build all and then just do an install. It should take less than a minute. It's like, takes longer to parse the project than it does to build it. It's funny. It didn't used to be that way. Alright, so a lot of it is C code, CC. Error. The design time build failed project. Build all until license might not be available. Set environment variable. Trace design time equals true. Restart Visual Studio to investigate. Oh, so it didn't build it or what? All right, it built it, but it threw some weird thing. Then build install. All right, it installed. Okay, it put it into install directory. Now we may have to reboot CMake. Okay, so we got gtest, gtest main. We'll keep this open until we build shader.rc. So what I like to do is just put a 2 right there. I like to just hit configure again. Just see if it works. It's just faster, and then just go and delete the other directory. So I have ksource shader.rc where the sources and where the build of the binaries, I'm in CMake, and the ksource shader.rc build 2. Let's see if it detects gmock like this, or do we need to reboot CMake for it to recognize the environment variable? Nope, gmock was not found. Configuration error. Even though everything else seems like it's fine. Okay, we reloaded. Let's see if it finds it now. Because the reloading, it had all my settings almost like ready. And if it doesn't work, we'll just try without gmock. I believe it'll just work. I think I built shader.rc like that. I was like, who cares about that error? What if I try anyway? Alright. Error in configuration process. Gmock was not found. Required for tests. Why? I do have gmock now. Alright, when it installed it, what did it do? It just copied all the files over, right? That's all it did. It's built, right? Yeah, it built. I have it. I don't know what shader.rc is talking about. Huh. It's just interesting. I'm guessing it's a very... So it says this was in third party. Google test. Oh, okay. So, let me go look at my other shader.rc somewhere. Let's see if I have Google test just like slammed in here. I don't know if I needed to compile that Google test. I go into my game engine I'm working on. I like working on a lot of things with the game engine, so I have things working in here. And semi kind of crazy. There's also the sparse v shader compiler. We'll be using shader C for now, but you could also use, I think, the sparse v compiler. I'm not sure. Okay, shader.rc built 2 in this. I know it built. I went into the wrong directory. Lib shader util. Wow, it generates a lot of projects. It just like spams a bunch of files. Okay. Inside third party. Yeah, Google test is in here. glslang, gl tools, headers, CMake. Huh, all this fun stuff is in here. Sparse v headers. ABSL. Now the question is, did I check out shader.rc the right way? When I did. Yeah, I put recursive. I don't understand why it didn't fetch everything else. Maybe they removed it. It's going to want all these other libraries, I think. So, like, let's go to case source shader.rc third party. Then inside this folder, run git clone recursive. https github.com google/google test. All right, .git. I don't know. You don't have to have .git at the end, or maybe you do. But let's see what that does with CMake. Okay, case source shader.rc build for configure. See if it gets rid of that error. But it seems like it's going to want all those other libraries. All right, Spark V tools was not found. Required for compilation. Uh-oh. So we do need more stuff. I did do the right thing. But sometimes you don't get so lucky, and you do get the right GitHub, but it's not the right version. And so you have to also have the right version. That's why I like when they make the GitHub to where it checks out the other GitHubs for you. And using the recursive command. All right, so we go back to case source shader.rc third party, run a git clone recursive, and we include github.com/chronos group/spirv-tools. This one's a little bigger. Wow, okay. Got that. The source code for that. Let's try again. Shader, case source shader.rc, case source shader.rc build 5, configure. And we need this for the shader compilation. It's just like kind of worthless without this. It's possible to do it without it, but it's not worth it. This is the problem with Vulkan and setting up a game engine. You have to get all the building absolutely thorough. I wanted to say perfect or not perfect, but thorough is the real word. All right, so we are missing the enable cell C++ and re2, which is regex, and FECC, whatever that is. I forgot what that is. Yeah, so we're missing 3 more. I see them in the other directory. In my case, I could just copy paste them over. I'm pretty sure that that'll fix the problem on my end, but I'm trying to do it the official way. Okay, GitHub, and then we'll just paste apecell C++. Apecell common libraries. Okay, guess we need this. And we are generating a bunch of garbage trash can build folders. Git clone --recursive GitHub/apecell. I don't know how people did this back in the day. It must have been just like people with like multiple hard drives where their heart and soul. All right, so we clone that folder. We'll go back to CMake for every single one because we want to make sure we're getting it right. We'll have to delete like 8 or 9 build folders after this just to clean things up. All right, finish. Shader.rc build 6. It's okay. This is just how it rolls. And all we're doing is like a folder detection. It's kind of stupid. I could have actually went and git cloned the rest of them real quick. It would have saved time, but we want to do this procedurally. All right, so now line number 59, apecel C++ is missing. Why is apecel C++ missing? It's here. Is there a subfolder? No, there isn't. How is that missing? Had surgery given. Or maybe it doesn't detect it because it just doesn't detect it yet. We need to refresh it. Let's refresh it. Yay, more build folders. Okay. So build folder 7. Case source shader RC build 7. Configure. This. Finish. We can close this down now. We need to be closing things down too. But sometimes you need them open. Right. I'm lucky I don't have to go through the Python installation procedure. That's always like funner. That asks you a bunch of stupid questions. All right, so no, it didn't detect it. Why? Which is not an existing directory? You're lying. It exists. Why doesn't it work? Abe Seal CPP. Abe Seal CPP. Let me go check my other one. Just want to look at the difference. Oh, it should be called ABSL. Right? Or wrong? Or there's another third-party library called ABSL. What's inside? Is it a clone of each other? No, these two are different. It's good that I have this already built. So I can just double check. What the crack is this? Pretty sure this is supposed to be the same thing. Where is it checking? Third underscore party, right? Yeah, this folder exists. CMake error, third party, CMake.list, add subdirectory, which is not an existing directory. It is an existing directory. That's why I'm like really thinking this is bad. Like, let's copy paste that directory directly into Explorer to prove that I'm not like having some sort of human error issue. Oh, it doesn't exist. Then how is that different from that? C source. Like, how's that different? Interesting. I don't know. I was hoping they misspelled party. That would be a good party then. What the? Okay, forward slashes. So what if we did forward slashes? Forward slash is gonna work. Oh, it doesn't work. Oh, do you see the error? I see it now. All right, let's modify our CMake file thing. Because the error is dash, not underscore. One it says dash, one the other one says underscore. Hooray, we found it. WTF. Who cares? I should have just went with the who cares version. Alright, whether or not this is going to work, because it might be a different library. Let's go back to GitHub for a minute. Do a little bit of like synapses here. Is there one with an underscore? No. I don't think GitHub supports underscores with the repo name. Like, let's try to create a repo with an underscore in it. I'm just curious about this. Underscore repo. This repo name is available. This is a bottom secret depot repo. Whoever reads this is gonna be like, the fuck? Alright. You can put underscores in your repo names, but we will go into our shader.rc third-party folder, into our CMake files, and instead of renaming the folder, we'll actually edit this, because we know we're correct. So we'll put a dash instead. We'll search for line number 20 abes cl c++ and put a dash in there. Just save it, and then done. This isn't in the root folder; it's in third-party folders. Then let's close this down. Reopen CMake again. Okay. shader.rc build 8. Not 9, 8. That'll build 9. We got 2 more directories to go. We'll probably get done by 10 if we're lucky. Wow. I don't think the other shader.rc had this folder. I don't know what's up. Maybe they updated it. Like, let's see what's in here. shader.rc build 2. I know this is built because I used it to build shaders. Yeah, it doesn't have that thing we just added. What's ABSL? I don't know what ABSL is. Maybe they're using a different... I don't know what these libraries are for, but it's always interesting to find out, because it makes you a better builder. Code builder. Okay, so we still need like 3 more. I thought we needed 2 more. Okay, now we need regex. I think we need regex, EFFCEE, and SFRB headers. SFRB headers should be a little easier. Okay, re2. We're gonna go GitHub. To Bing or Google. re2. Regex. We'll also add the regex to kind of explicitly tell it. Okay, so it's github.com google/re2, and it sounds like it's the correct one because it's made by Google, so they pretty much keep a good everything on it. Because there's other sub ones. There's CV2, Python, Google projects. Yeah, it's like a huge consortium project. V2 is a fast thread-friendly alternative to backtracking regular expression engines, those used like in PCRE, Perl, Python, and C++ library. Of course we need this. Okay, I like regular expressions. I used to like code a lot of them. They're like really difficult at first, later they get fun. Alright. I don't know. I think some people like went mad over them, but that's just my opinion. Alright, so we got re2, we got regular expressions. What if we cheat and just put a 9 in here? Oh, don't do what I did. Blindly put numbers in the thing. Okay, K-source, shader.rc build 9. Should need only 2 more. And we should have a spanking brand new shader.rc to use for Vulkan 1.0, which which is kind of weird because the reason you would use Vulkan 1.0 is so that it's backward compatible with Vulkan 1.1 on Android and Vulkan 1.0 on Windows 7, and maybe some other things that I didn't even think about that introduced Vulkan 1.0 or 1.1. Anything under 1.2. And they're like Raspberry Pi is 1.1 also. Okay, so we need this FECC library. Like, I don't know how you read that. Let's see what it is. GitHub. EFCEE. Oh, it's also a Google library. What do you know? I'm like very surprised. EFCC is a C++ library for stateful pattern matching of strings inspired by LLVM's file check. Okay. So it's just another regular expression thing. Oh, a lot of these are like regular expression things. So we're essentially what we're doing at this stage is building a compiler for the shader. And that's like, we're building like a little mini compiler for Vulkan to use at runtime or non-runtime. You could actually, you usually precompile the shader. It's kind of like you do in Source SDK engine and some things. And some things you precompile the shader, some things like, I like how OpenGL does it and just does it runtime. And I used to not like that. I used to like be viciously afraid of that. And then later I was like, oh, this is great. We can just compile the shader while we're working on this. It's so cool. All right, shader RC build 10. We have this EFCCEE and third-party library. Figure we have more regular string parsing capabilities, but we still have one more library missing, the Spark-C headers. We have the Spark-C tools. We should get one more error. Getting rid of our errors pretty consistently here. This is very good. And this is the thing. This is like 0.5% of the headache is first just starting out building this. And later on, you can just go to sleep and we'll wake up and just start coding and doing stuff in Blender and the actual things that matter. It's kind of like, seems like the most unworthy thing to do. But it's like required. So if you can do this fast and you understand it, you're like in big luck. So GitHub, and we'll just search /external. So it's set external, but in reality, we're going to grab the GitHub /Chronos group Spark-C shaders headers. It's these ones. It's from Chronos group. This is, so you know it's just like going to be legit. Get recursive, get clone, not recursive, recursive. HTTPS, github.com, Google, Chronos group, Spark-C shaders. Okay, so we got a bunch of stuff from Google in Chronos group and some other consortiums. And we should be ready to have K-source shader C build 11 generate or configure, and then we'll generate it. And then we got to go and do a little bit of throwing stuff in the trash in our C source folder. K source folder. I might have a little bit of trash in here. And it's so much trash that this is like a required takeout. This is just like targeted. So you see how they have all these shader RC build ones? We don't need any of these anymore. They just have like a stupid file. And in order to like clean them, the easiest way is Shift Delete. Yes, that'll permanently delete them. So it's deleting them while I'm building. Okay, we still have a configuration error. GSL lang was not found. Okay, so we're missing one more little thing. And in the meantime, we wiped out 10 build folders. Okay. So, oh wow, there's like more parameters. Look, from the original, there's only this many parameters. This, we have this many parameters. All right, so skipping simple exports for tests. Google mock already configured. Can't find fuzzy data provider.h. Won't be built. I wonder what this is for. But this is like another building. What is this? Will this tell us anything cool? If we like go into Google. We'll ask the AI what this means. Google recommends using Chrome. I know that. That's why I'm not using it. Okay. Issues. Cannot find. Why did they delete everything? I don't know what they meant by that. Wow, there's not much of information on this. Other way to do this. Go to Google, just type that in. Oh, okay. Where would we dump this into? Can we just get the file and dump it? Oh no, this is like in the middle of everything of RT compiler and LLVM. Now I have LLVM compiled. I don't know if I have it installed. Okay, so we're not going to worry about that. That's just a rabbit tunnel leads to the center of the earth. Okay, GLS lang was not found. We'll just concentrate on getting GLSL language library, and then we should be done. We're not going to worry about LLVM related madness. It's great to get into, but if you're just trying to do, I mean, you can compile Vulkan itself with Mesa 3D after you compile LLVM. That way you compile everything, because that's the point. Okay, so we went to the GitHub page of Kronos group /GLS language, which is the Kronos reference front end for GLSL, which is the OpenGL shader language, ESL, partial front end for HLSL, and SparkV generator. So this generates the, I want to say bytecode or assembly code for the shader. I hope that's what that is, or it just said something stupid. Git clone --- recursive and GLSL lang GitHub repository, clone it, blah 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 blah. Go back to CMake, set our build directory to kshader c build 12, and as soon as we receive 1 more %, oh wait, we just need to resolve the deltas. Updating files. Okay, done. Build. Okay, finish. Could have just like built the Vulkan SDK and just like started from that. But the way they do it is that they kind of hide everything under the hood of the samples. There's different samples that are possible to build, and some of the stuff is kind of done for you in some case scenarios, but this is really the core building the engine. Like, you might not have this, even this fuzzy data provider thing, but there, configuration done. We've configured it. So we want to install this into ksource shader rc install, like we did with the other ones. This was the hardest one, I promise. Alright, so shared libs. Do we want shared libs for this? Yeah, let's just do it. Build gmock. I don't know why we need to build gmock, but whatever. Build wr? No. Let's just forget about everything else. Disable exceptions, blah, blah, blah. Build, enable exceptions, blah, 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 blah. Enable spark_sv, that's checked. We'll just leave everything as is. Tensors, no, we don't need to run more tests. RC build framework, no. You could build some of this, would be nice. Where the source code is for all the headers, the Golang, Google test, spark_sv log, engines, log, blah, blah, blah. It'd be good to have the debug log for spark_sv. Let's enable that for newbie testing stuff and breaking it. spark_sv header enable install. Let's enable that. Oh, whoops. It's not. Okay. Just screw it. Use PCRE. No. Generate. Then we open another copy of Visual Studio once we generated our shader.rc build 12. For you, it might be 20 because, yeah, Python failed and pretty sure something else failed multiple times. It just always does. When you compile these multi-consortium libraries. Okay, open project solution. Fucking shit. Can't even copy paste, it's like getting so sluggish. Alright, why? Why can't I open it? Oh, I pasted in the wrong place. Like, you used to be able to paste right here. I don't know, for some reason this file dialog, you can't do that. A lot of file dialogs you can. I mean, edit box dialogs and file dialogs. Okay, our shader.rc is .slnn. Okay, let's load up shader.rc and hit build as fast as possible. Just watch it crash. Just like Google Mock. Because Google Mock, we built it, but we actually built it for no reason because this thing builds it anyway. Like, watch it. It'll be inside here now. It, like, has another CMake file for all this stuff. Yeah, look at this thing. Just like a dumpster full of just shader parsing laser meat grinder. Okay, it is a laser meat grinder. It sends a bunch of LEDs in our face once it compiles the shaders. Okay, so what do we have to do? Like, where's build all? Tests, CMake predefines. Yeah, CMake predefined targets build all. That's what we want. I don't know why AMCell is the first one. It's just like they didn't organize it, but whatever. I guess they had to do it that way because it's like pre-dependent or something. Alright, so it's building. It's going to do all this stuff. So once that's done, we'll have the shader.rc.exe and we could just like make a little shader. Alright, time for Vulkan stuff. While this builds, should take like another second to build though. So the Vulkan, I wanted it to open it in this window. Now I can't because I've ruined my plan. I don't think it was this window. No, this can be trash. Which one was it though? It was one of these. Uh-oh, I lost it. I lost it in the process. Maybe it was a Firefox window that I closed. But anyway, let's just go Vulkan specification 1.0. We don't want 1.4, we want 1.0. So it takes you to this, all these pages, like latest. It'll try to take you here and convolute you to read 1.4, which is not what we want. We want 1.0. So I don't know what this Vulkan StarCraft thing is, SC. But SC stands for StarCraft. Everybody knows that. It doesn't matter if you're in a graphics engine, high vocabulary of scientist, from a professor degree of a college, university of the space rocket program. SC will always stand for StarCraft because StarCraft is in space. And if you're a rocket scientist, you should know better than to mess with like StarCraft. Anyway, I don't even have StarCraft installed. I'm trying to make my own RTS. It's a lot more fun than sitting there trying to grind XP. Okay. I'm lost. Like, the specification document sucks. It's like too long. So okay, I'm gonna save it so I could print it out tomorrow and waste like every inch of the paper I have. So I have like Android Cookbook, DirectX 9 programming. I gotta learn DirectX 9 because it's a really good fallback renderer that'll work like on everything. And if you compile it also in Windows like 7 and VK specification, you'll have like pretty much everything covered, including Android or something. All right, so does this tell us how to write a little program? Or it just bogs us down into like reading about every professor that tried to do this? I mean, we could visit everybody's like LinkedIn page. We'll find some really interesting people. All right, so Spark's Resource API. Let's go read about this. Physical device features. So VK image, we need to generate an image. So we need a texture. So Spark's binding, support for creating VK buffer and VK image objects with the buffer create sparse binding bit and VK image sparse binding bit flags respectively. Okay, let's go read about VK buffer for a second. I know like what buffers are from like OpenGL. They're just like arrays or something. Provided by Vulkan version 1.0. All right, so this is another thing we should open. This reminds me. Vulkan API table. Latest. Now we want the table. Let's go look at the images for a second here. Instance, physical device queues, heaps, application device threads, command pool, descriptor set, command buffer. Then we have command buffer, rendering dispatch, subpass, dynamic state. All right. I didn't make this like. I gotta print this out really. Save it. A lot of these are really good images, but it's just like, am I gonna save every image in Google Images? No. The other good one is, I think, Vulkan 1.0 cheat. We're not programming anymore. I'm just browsing Google. Specification. But I saw it down there. Like, it's this. It's this thing. No, it's showing me garbage now. Like, it's not this. R for data science? Like, who the fuck programs R? Sorry. Vulkan API quick reference. This is the thing I need. They like make it really difficult to get this thing. It's all like on Udemy somewhere. They don't want you to have it. It won't open, will it? Okay, it does open. We can't zoom into this. I think it's like this blurry on purpose. Like I can't read this. Okay. The next thing after it's still building shader.rc while we're doing this test reduce. So it seems that it's perfectly booked. Sorry. Perfectly fine, except for a few little bugs. Let's see, 80 errors. That's not that bad. 28 unresolved externals. Oh, really? That's bad that it's this. Is that because I told it to build a shared library? Getting this type of bad treatment? Yeah, glslc.exe. That's the one we needed. Error writing to program database. Check for insufficient space, invalid path, or insufficient privilege. That's not too bad of an error. That's what we really need. We just need this thing. So it worked? Huh? I don't understand how that worked. Let's build all again. Getting some library linker errors. Shared. Yeah, it does not like building the shared out of the box. Probably different Google libraries and Chronos libraries together. How do we fix this? The classic way is just to go like this. See if it'll find this first. This is error number 1. There's like 80. And we haven't written one line of like Vulkan code yet. Nice. Okay, so I didn't find that. Okay. What is this? Search for Spark V tools, colon Spark V tools. And we get this. What's wrong with this? What it says is it's already defined in the library. And it's trying to compile shader RC. But Spark tools, Spark V tools is also a shared library. So it doesn't like having one shared library with another shared library. We can go and turn that off just to make the error go away. But it would be interesting to build it anyway. Okay, which project is contained in? Tools, build, examples. It's not examples. Okay, this open. Should be in this. OpenCL debug info. Okay, so this has some sort of compute of the CPU. some sort of side note here. Okay, it's this one. SparV tools shared. Yeah, that's what it says. A lot of it is in there. SparV tools.lib. lib SparV. Yeah, it did find this SparV tools, but shader.rc shared. Shader, but it's not finding it in shader.rc shared. Damn it. That means it's stupid. What I think is happening is it's loop linking. Okay, let's go into project solutions properties of all the project. Oh, we can't just modify everything, can we? This is a debug 64x build. I should have actually been paying attention to all that logistics nonsense. Okay, let's try select all of it like this. Hit properties. It won't crash. Try to do this. Can we modify all the properties of all the projects at once? I don't think that's a good idea. It's not even working. It just ignored what I did. Okay, shader RC. It's not the bottom library. We need to worry about the bottom library first. Or should we try the top? Where do we find it? Okay, it's in here, right? Sponsorship tools shared. How are we building this? All right, dynamic DLL, C++11. And we need to go into the linker, I believe, and change it. Okay, enable increment linking. No. I don't want any of that weird crap. This won't work anyway. Alright, disabled increment linking, optimization, system, console, no console, debugging, general debug information, C++, let's go into C++ general. Treat warnings as errors. We really need multiple process, disable optimization, disabled preprocessor. Code generation, okay, code generation, enable security check GS. And we can disable that. Enable C++ exceptions. Yes, with extern C functions. I have to turn that. Basic runtime checks, both RC equals. No. How do I say no to that? Okay, it doesn't let me. It'll do something weirder if I try. Language. Okay, language. Okay, so we changed one thing. Let's see if that helps. I think I changed, I forgot okay, it built that. What I changed was in linker, I believe, I put incrementing build no. That I was able to figure out only one thing. I could kind of hack away debugging. allow isolation. glslc.exe. Okay, shader.rc build. We actually need shader.rc. Okay, shader.rc works, so we built that. Build shader.rc shared. Okay, so now we have 10 of these errors here. Only when we try to build shader.rc by itself. But if we try more stuff, I'm pretty sure we'll get more errors. Okay, already defined in shader.rc lib. So I'm not sure if stuff went away. Because what it should be happening, it's probably referencing itself somehow. Like, how is that inside this file if it's inside the other file? Beautiful. Search for this. Dig down into the deep of this. So this is inside the wrapper. Spark Tools wrapper. It's inside shader lib tool source, includes shader tools. That should be a part of the same thing. And then binary to text test. Spark speed tools. It's inside text. What is this a part of? Spark tools. Shader RC util. SPR tools wrapper. What's the difference? Oh, it takes us here. But it's calling this function, it's not declaring it. That's stupid. It's declared in here, right? The tools shared library. And it just returns binary with options. Dun, 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 dun. I knew that this might happen. Well, there's like two options. Just go to Grok, tell it to write a specification program, try to compile it real quick, be done with this. Or this. I'm trying to find like multiple. It's only defined in this text.c++ thing. I don't understand how it's finding two of them. If there is two of them, I should find it like this maybe. So this is the export. So what would happen if we hit install? It just won't work or what? I'm just interested now. Let's try build all again. Get the errors. Blah 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 blah. DLL failure. It's mostly unresolved. Yeah, I think we got the wrong library. That this is what happened. They updated something because this one required more libraries than the other shader RC I have that is working. Or it's because I built shared. Or I built with that one extra option. So, I think the quickest way will be to, let's do build 13. Configure, yes. All right. Put this in the top of our file. So we're really going to need this. Our preamble. All right, so to rebuild this, we're just going to build gmock. Okay, we'll just leave everything as default except for make it install 2 will be the install folder. Maybe one day I'll figure out what I have to do, but to build it like that. But there's other things to build, even like LLVM and Vulkan from scratch. Okay, case source shader RC install 2, and we'll just leave everything else just default. And then we'll quickly make our Vulkan file. So go back to our Vulkan project. We have glfw. We'll put the specification file in it in case we need to reference it later. And we need to speed this up because I have to go to sleep like soon. I can continue this on tomorrow and do a more thorough job of the Vulkan side of things. So I've tried to use this before on it. We can try this. Write a Vulkan 1.0 in code C. This is the way I didn't want to do it, but oh well. To display a sphere with subsurface shader. Let's see if we can do this. It'll give us the basic layout. Alright, so to display subsurface shader in Vulkan 1.0 using C as a complex text requires significant setup. Vulkan instance device, swamp chain, render pass, shaders, buffer management, and more. Below is a minimal and not standalone code sketch to give you a foundation. Alright, so it gave us some shaders, good. We can try to compile those using glslc.exe validator. And we have glslc compiled, I believe. Alright, so create pipeline. This gave us such a bad code, but we can get started somewhere. Sasha Williams samples. The thing about this is that we're trying to do this at 1.0. Alright, Vulkan.h doesn't work. We have to fix that then. So we go to properties. We have to include our SDK. I installed my SDK into K, Vulkan, SDK 4. Oh no, it's just Vulkan SDK. And this is going to take the Vulkan include library. Yeah, so it's going to be K Vulkan SDK / 1.4.03. Or, sorry, 1.4.3.041. Oh, and there might be an include library. And a bin. Alright. So let's add the include and bin library real quick. So include library bin, so just add a lib in the back of this. And library directories, if you go into your project property pages, VCC directories, add the lib of your Vulkan SDK, the lib folder inside Vulkan SDK / the version number, which is 1.4.304, and include, add the include, and hit OK, apply, and then OK, or else it might not register. Alright, so Vulkan.h, try to go to document. If it goes to document, it means it works. Then go to VK platform, hit open on that. That works, and it keeps going. However, how long, you can just check out Vulkan core.h. How big this is. Oh, this is like a small file. It's only like 20K. Actually, it's not that small, but it's not super duper large either. And it's calling a bunch of these DLL style functions. It looks very OpenGLES. It's like the same idea. Generalize everything, but you get a little more control, I guess. Okay. Learn Vulkan Intro 1. So the problem with this is this gave us this stripped version. It just gave us the idea that we first need to go. So first we need to create an instance. So okay. So let's add a file called new item. And we'll name it create instance. Did I spell instance right? No. Okay, good. Genius. Instance.c or something. And we'll just go void create instance. And then we'll go another file called create instance.h. And create instance.c. We'll probably have to include create instance.h, or maybe not, I don't know. And then we'll include, we'll make this other file called like learn Vulkan common dot h and put include create instance.h. Copy paste that a little bit. Go to the intro one and do create device, the lowercase, create the device.h.c. This way we can have like a really clean file at the end. This is so annoying. It's just like, what a lagging way to live life. Or declarations for brevity. Okay, so we got done with that. We're working on this. So create device. So how do you create a device? Alright. So we got create instance, create device, create swamp chain, create render pass. We also need to create the shader pipeline. There's a few things missing here. Even just from like little Vulkan. It's going to be interesting how I pass this back and forth between multiple files. Alright, so let's see. Did shader.rc compile or did we get the same type of bloatation? Oh, we still have to compile it again. I will figure out what's wrong with this, compiling at all this shared DLL mode problems. It can be static. Because while you're working on your game engine, you could figure out how to fix this to make it DLL. This is a builder's fun job. I mean, I'll figure this out, but it'll just be like watching videos on stream, copy-pasting into Google. So once you figure out like one of these errors, a lot of the other ones go by real quick. It'll just be like reading up on like some flag you have to set or some other version you gotta go get. That's basically what that's gonna be like, I think. It'd be interesting to fix that on stream. Alright, we'll go to case source shader.rc build 13. Any kind of special flags build. And hope it builds. But I still have a shader.rc build that's already built as a backup. So you need to have shader.rc. You can just download it, I believe, too. But building it is the preferred method. So then you can modify things and fix things. Or you can get updates and do it yourself. Make sure you don't download a hacked binary and get a virus. That's also another reason. Dun, 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 dun. And let's see if we get the same errors, which we probably will. I don't see the shared library, or is it here? It's probably in here. Yeah, it's in here. Shared.rc is in here. Maybe less stuff is in here. I don't think I saw any errors, but I could have just like looked the other way for a second out of fear. It's a really scary part of this. I don't know, people are into all these like little stupid horror games. This is the most horrible horror game in the world. Watching code compile that you know is really long, it can get really gnarly errors. Cause you just nights of pain. Dun, 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 dun. Seem to be doing good. I see EXEs. I see some EXEs and .libs already. You're doing fantastic. Come on. Build successful. As soon as I say that, the arrow will pop up. It's just like, ta-da. All right. Just watching it build. This is bad. GSLang. Standalone. This is the thing we need. We're just going to need that. All right. We fetched it. All right. Build mesh, main loop. Let's add our shaders. Well, we kind of want to build the instance before we do any of the shader stuff. I don't think it's this that we use. We use shader.rc to compile it. I think Copilot might tell us here. Let's see, tell us. All right. Subsurface.vert. They gave us these interesting shaders, though. They're not long. The subsurface.vertex shader is a very common shader. It's just basically make a camera with 3 matrices. Make a subfolder. Shaders. 4.5. 4.5 for the version. We can have lower versions for older graphics cards. New item. Subsurface.vert. Oops. We want to name it of what it represents. Can we copy paste the name? No, we can't. We have to actually manually type something. That's bad. I feel like my life was just lost on that whole little endeavor. Okay. And then we'll add another file. But we do want to kind of do it the way I did, because that way it stays in the main directory of everything. So when we call fopen us. I don't know if I'm spelling subsurface right, but it's already getting late. That's why. This y is y here. Okay, subsurface.vert. Matrix, projection matrix. It should by now, Visual Studio, once they update it, it should actually understand .frag and .vert files and be able to highlight this, which they will have to compile their own shader C into Visual Studio. That's funny. I wonder what they're going to come out with. They should just do a simple down version of Visual Studio 6 with a few highlighting. No IntelliSense. None of this garbage that they've been pumping. Oh yeah, we're going to have IT fucking AI. It's horrible. Yeah, it's the worst thing. It's already gotten itself into this. Okay, create device. Um, 706 errors. We did it so much better on the other one. Alright. We know we compiled something in here. 170 projects. Okay. Let's ask it how to compile shader. I wanted to ask a more precise question, but I don't understand. Can we go back to what it said? Yeah, okay. Oh, we need the glsl validator, right? Let's go to our project. But why isn't it this? Why is it the validator? Let's go into this folder. Okay, source shader RC build 13 third-party glslang standalone debug. I think it's like building the things we need to compile the shader, but it's not building some of the other crap. It's just like irrelevant to try for now. So we go into CD, wherever we build shader RC into, in the third-party directory, and there's this thing called glsl validator. Hit that, copy paste its name, copy paste our shader name. Can we run this in a different directory? Can we just like move it? I believe we can. Or we can point it just to this file, which is blah 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 blah. How does it say to do it? It says to put O or something. Yeah. So we're going to execute. We're going to tell it to execute like a long command. I believe F is going to be our flag and O is going to be our output. So we're going to output we're going to put glsl validator minus F, the path to our shader, which is K source repos, Crime Wars 2000. Oh, I didn't mean for that to happen, but Crime Wars 2026, Vertex Animation OpenGL3, which is actually our Vertex Animation OpenGL3 again, Learn Vulkan intro. That's what it should have been. And then subsurface.frag space minus sign O subsurface.frag.spv. And in front of that SPV, we're going to add this whole path. So it like throws it into our project folder for us. So I'm doing it in here. So like later when you have to keep rerunning this sometimes for, and we'll just come up with the other command as we're doing this. This one will just be minus sign v, vert extension, and then change the extension of the output so you don't mix up the fragment. And let's try to run this. Okay, we run it, gives us helps. Run. F is unrecognized command linker. Okay, we did something wrong. V version, create specific binary semantics. Okay, do the shaders contain what they are? No. I mean, you know by geoposition. How does it know if it's a fragment or a... Okay, this minus F thing is something I hallucinated. So humans can do the same thing as AI, but just different ways. Let's just do minus V. That's why I'm compiling fragment shader first, because I'm more unsure. Okay. Either way. Okay. Okay, I think we got the fragment shader done. We'll just like CD into that of where we put it. Dir, K, colon, dir. Alright, so we did get the shader file. It's 2 kilobytes. It transformed from 804 to 2 kilobytes. Cool. So now we do this shader file. Okay, so our shaders are done. Cool. Oh, let me read the shaders, make sure. The fragment shader looked fine. Okay, the fragment shader is the one I need to really read. Okay. What it does is fine. Just has some colors in the normal and a color. There's no even texture in this. That's the main thing. If it does something weird and stupid, it'll still work. Because we only have 3 vertex attributes. Why is location out color location 0? Oh, I guess it's because it's an out, not an end, right? So it changes layout. Yeah, okay. Frag position, frag color, frag normal. So that's being calculated in vertex. Oh, interesting. And then that's how it lays out the uniform. It looks different than like what I'm used to, but you can still read it. Okay, create device. How do we do that crap? Create device. Let's look at their specification file. Specification 1.0. How would we actually start doing this? I've done this before, and I have like I'm GUI. Like, there's other ways of like achieving this without having to like learn. You still learn because you can just go read the code. But the best way to learn is try to make a video about this. Maybe like jump into a bunch of rabbit holes real quick. Like, I can't get out. What the hell? Okay. Fundamentals. I don't want to read any of this. This chapter introduces fundamentals of Vulkan architecture, execution, API syntax, queues, pipelines, configurations, numeric representation, state and state queries, different types of objects and shaders. All I care about is shaders and like reusing the same vertex object for everything. That's all that matters. Well, not really. It's also like I want to be able to use that multi-thread thing they have. It doesn't even work, that multi-thread example that I have, so I guess it's not always like as great as they say it is. Everybody just runs on one thread. It's like a fucking graphics thread. So whatever the problem is on my CPU, it's going to be on this other people's CPUs also. Don't have certain drivers installed because they're using hacked motherboards. VK true 1, VK false 0. I could have guessed that. VK boom. Device size. Device address. 64-bit. Threading behavior. Output is intended to provide scalable performance when used on multiple host threads. All commands support being concurrently from multiple threads, but certain parameters or components of parameters are defined externally synchronized. This means that the caller must guarantee no more than one thread is using such a parameter at a given time. Who cares? More precisely, Vulkan can use simple stores to update the state of objects. Okay, so like you have to be like precise or something. External synchronized parameters. VK destroy instance, VK destroy device. Submit queue. We might need these. VK destroy instance and VK destroy device. Cleanup. device. We need these. Alright, what do we do? Just pass the instance in here. Allocator callbacks. Yeah, there's this thing like descriptors or something. They'll have like callbacks. Instance. I don't know what you pass into that other part of it. What's the callback? Allocator callbacks? Allocator callbacks? Alright. VK create device. Alright, good. Goes into this. Create swap chain. Create device. Okay, add device to Vulkan common. I haven't put anything into create device, have we? No. There's nothing in instance or device. Okay, let's put something in instance. I was trying to read the specification of what this is. What is this? Create instance? Where is this? Oh, it's in here. How do we do this? Provided by 1.0. Okay, so create info is a pointer to VK instance create info structure controlling the instance. What the hell is that? P allocator controls the host memory allocation, describes the memory allocator chapter. Is that the CPU memory or the VRAM? I like to think in terms of like neutrinos and Raspberry Pis. It makes it easier. It's all the same crap. Well, no. That's the bravery part of it. Okay, instance create info. So we need like one of these things, I think, too. At some point. We need it in the function. Alright, let's go in here. Slap that in there. And then, what we'll need is we're just creating an instance. At the very beginning of this. Like, what do we do? Just pass in a reference and shit? I'll just do this. PK instance star instance. Put that into a header file. I don't like this program at once. I like the old classical way. You have to do an ifdef everywhere. Undefined. Okay, I guess I have to actually include a file manually. Okay, that'll do that. Even though it'd be nicer to include only the file you really need here that defines this. Where does this get defined? Vulkan core. What if we do that? What if we just go like all out fucking hardcore? Okay. I'm guessing we're gonna need to only do it like this. There's no way around that. Alright, create instance. We're still on create instance. Wow, this is bad. We've already created our shaders and we're still on create instance. Go to definition. And we can't go to the definition because Visual Studio is too dumb to recognize C code when it's broken. That's, I mean, pretty stupid. Alright. What's this? Oh, okay. Yeah, so I wanted to actually just trying to figure this out faster. What's the allocator callbacks? The allocator callbacks are, let's see here in a second. It's like, wait a minute, something's wrong here. Wrong Visual Studio stuff. Alright, yeah, okay, create device, create surface, create instance, okay. Oh, this is where we get to specify stuff, like the Vulkan version? Okay. So this is the create instance function. It is the create instance function. Now, what we want to do, application version 1.0, 1.0, API Vulkan version 1.2. Now we want 1.0. This is really what we're, VK version 1.2 is a preprocessor guard. Do not pass it to API calls. Why not? Patch should always be set to 0. What if we set this to 1 underscore 0? What if we do this? Is this defined? Yes, it is defined. Vulkan 1.0 version number. Patch version should always be set to 0. Okay, BK make version. What does this do? Variant, major, minor, patch. Okay, so the minor is 0. Kind of know that from OpenGL. It's like the same concept. We want another variable in here. Int I created, oh, what do you know? I created instance equals to 0. Alright, so it doesn't have this Win32 surface extension name anymore because of the version. So what we did is we created the VK application structure. We're going to call this Vulkan Learn 1. Then we call app.info.application version make version 1.0.0. App.info.engine name, no engine. Learn engine, I don't know what this thing is for. Maybe it should have been no engine. Engine version, make engine version 1.0. API version. What the hell does it use this for? Okay, that tells me a lot. Okay, create instance. success. VK instance create info. Here we go. To the type, the next, the flags, the application info. Create instance info has an application info. So this is a sub. Okay, next is some sort of chain. Type is some sort of thing. Validation. Here we go. Application info, engine name. What does engine name do? Engine version is unsigned, blah, blah. Developer of engine is created, which engine name is null or a pointer to a null terminated UTF string containing name of any engine, if any. Because of application. It says UTF string. This is not a UTF string though. This would be a UTF string. That doesn't work though. Maybe this is a UTF string. Would that be taken? What about application name? Is that a UTF string? It probably is. Yeah, it is. I shouldn't worry about that too much though. I don't think that's a UTF string. I think it's a wide string. I would need to like include something for it to do that. Oh well. Okay, so let's say we created the instance. Somehow this went well. Create info. Okay, so the create info doesn't get past anything. What else do we need to specify? Application info is equal to. How does this not even have this code yet? So that just doesn't work. We can't just do that. Oh, cannot assign to entity of type const application info star. Really? What if we just do this? Are we allowed to do that? I guess. Create device, right. Swap chain, the next file will be named swap chain. H. Just need to define this real quick. Just get this kind of like sort of prepped. I want to code create instance first. This is annoying the way I kind of left this create pipe render pass. There might be more functions. There's also I think create pipeline will have the shader thing. Shader pipeline implementation. fancy words altogether. Oh, I love the naming of this. It's like in lowercase, you can't tell what you did. Okay. Create pipeline. It's getting there. I knew this was going to be like super long and stupid, but I thought I was able to do it like in 5 minutes. Oh yeah. I like proving myself wrong like this. Okay. I can all dump these into a folder once I'm done. Even main loop can go inside of its own folder. Shader module. That should be also its own function. Create sphere mesh. All right. Need another one called create shader module. Does it create shader module or create shader pipeline? It might be both. BK create shader module and create shader module. Return module. do is move this. This is the interesting part. The auxiliary code fixing before going back to all of it. Okay. Now going back to create instance. What do we need to complete this? Enabled extension count 2. I think that's going to be 1. GPU assisted X, debug best practices, debug printfx. Alright, so this can like print stuff too. This is where our code shines. The one that we wrote. We can literally copy paste just like all of this into our code. That way we could like read it and manipulate it at the same time. Is this layers already? Oh wow. Did it not copy paste the right way? Where did this start? Yeah, it like lost. It lost it. Okay, instances. Creating physical device from device extensions. It didn't even. You can't even copy paste out of this document. Can you? Let's try. Oh, okay. It's good to keep like a lot of documentation inside your file like this. Right out of the Vulkan PDF. I guess we have to copy paste page by page. We'll just do add page. I'm gonna go to sleep. It's ridiculous. I mean, like I could do this all night. It's really long. This is page. I don't even know what page this is. It doesn't say. They didn't provide page numbers. Oh, it's page 70. It's up top. Page 70 out of 1,000. Wow, that's interesting. Yeah, I'd rather do this tomorrow. I mean, I could go and copy paste everything else off the other computer right now. Create surface. Because this has the creating the window portion of it. I don't know if this uses Win32 or glfw. Yeah, this uses Win32 method. So here's the shader modules. This is how this creates the shader module. It's the same as the other one, I think. Oh, it's similar, but this is using C++ vector code. So it's a little different. I have the instance, physical device, the device, the surface, the swamp chain, the render pass, the pipeline, the command pool, command buffer, the VK buffer, memory device, index buffer. We also have to have an image view, and we have to create a class for that. The vertices, the indices. This is using 1.2, which I think this supports. So create surface is window. And I don't think this has... It has a win main, but it doesn't have the window creation with the handle. It just creates the surface. Oh no, here we go. Yeah, H instance, create the window like this. We could try to do it like this also, but if you use glfw, you will avoid cross-platform errors later. And this is how you read the file and then create the shader module. Yeah, so if you keep implementing it and just debugging it, we'll get through it. That's missing. Graphics Q family index. Alright, I have to kind of just pretend I did something at the end here and just show something else up. Well, it worked. It's just that it took too much time. Yeah, so it'd be fun to get it to this point. Or on this is a vertex animation actually. It's changing the vertices instead of